Alright, in this video we are going to look at finding sides of a right triangle using trig. If you're watching this, you should already have a basic understanding of how to set up the trig ratios. You should know what I mean when I say SOHCAHTOA, because I'm going to use that several times to do this. It's very important to being able to set up the equations we will need. How we're generally going to do this is a lot like our setup of the trig ratios. We're going to pick an acute angle with known measure and label the triangle. Then you're going to write an equation and solve. The last step in this will be to use the calculator. Speaking of the calculator, if I pull it right here, if you go on your calculator, this is if I hit the mode button. This takes me to the mode menu. Most of these things you'll never have to use, but you will most definitely have to know this. If you go down to the third line, radian is probably what your calculator naturally has highlighted. Radian is not the mode that we will need to use. You'll need to change this to degree mode. So I'm on the third line, I go to degree, and I hit enter. If the calculator is not in degree mode, you will get all of these answers wrong. So please, please, please make sure that you do this, and you will have to know how to reset it yourself. So I have my calculator in degree mode. Now let's put this to the side, and let's look at how we actually do this. I'm asked to find each variable to the nearest tenth. So I've given you a right triangle right here. I can see that the hypotenuse is 29. The leg adjacent to this angle right here is x units long, and this is a 39-degree angle. So this is given to me as 39 degrees, so I might as well use this angle. Looking from 39 degrees, I see that 29 is the hypotenuse, x is the adjacent leg, and this leg is the opposite leg. Now I'm not asked to use the opposite leg. I don't need to find it. I don't know what it is, so I will actually not use it at all. So now what I'm going to do is write an equation which I can solve. So trig is based off of setting up these three ratios: sine, which is opposite over hypotenuse, cosine, and tangent. So if I am not using the opposite leg, it doesn't make sense to use sine or tangent. In fact, if I need to relate the adjacent leg to the hypotenuse, I know the adjacent and hypotenuse are related by the cosine. So the cosine of 39 degrees is x over 29. As I do these different equations, these different problems, you'll see sometimes you might have to use some sine, sometimes you might have to use cosine, sometimes you might have to use tangent. Which trig function you use is determined by the triangle, which information you're trying to find. But no one trig function is more difficult than the other. The difficulty will come based on which sides you're actually finding. We'll see that in a few minutes. Let's come back to this. Let's solve this. So what I need to do is multiply both sides to get x by itself. Cosine of 39 degrees. This looks weird. This is ugly. But all it is, ultimately, is just a number. The cosine of 39 degrees is some number between 0 and 1. If I want to solve for x, what I need to do is get rid of the division by 29. I multiply both sides by 29 to do that. 29 times the cosine of 39 degrees is equal to 29 times x over 29. But the idea there is to get rid of the 29s. So this means that x is 29 times the cosine of 39 degrees. That's as exact an answer I can get. I was asked to round this to the nearest tenth, so that's what I'm going to do. I'm going to grab my calculator now. I'm going to quit out of here. Alright, so I needed to find 29 cosine 39 degrees. So on my calculator right here, very obviously, there's sine, cosine, and tangent. I'm finding 29 times the cosine of 39 degrees, so I'll type it in just as it looks on my paper. 29 cosine 39 degrees. I don't need to type in a degree sign. I should close the parentheses here, so I'll do that. And then I just hit enter. So the answer I got is 22.537, and there are several more numbers here. I was asked to round to the nearest tenth. To the nearest tenth, this will be 22.5 because I will round down on 3. So x is approximately 22.5. And I'm done. Let's take a look at another example. This triangle right here, it looks a little bit different. It's oriented differently, but the other big thing, the 90-degree angle is not marked. However, I'm given a 25-degree angle and a 65-degree angle. Well, 25 plus 65 is 90. If those two add up to 90, that means I must have 90 degrees left, so I can use trig to solve this. The other thing is, I know both acute angles. Should I use 25? Should I use 65? It honestly does not matter. The setup of your problem will be different depending on which angle you use, but if you solve it correctly, you will get the same answer. I'm going to use 25 degrees. If I'm looking from the 25-degree angle, then I can see that the sides of this triangle are, down here is the hypotenuse. You can write that if you wish, but we're not going to ultimately use it. Y is the opposite leg, and 13 is the adjacent leg. Now, I need to use the trig function that relates the opposite and adjacent legs, which is the tangent. So I can say the tangent of 25 degrees is equal to y over 13. All right. Tangent, again, opposite over adjacent. That's why it's y over 13 as opposed to 13 over y. Please, please, please be very careful when you're setting these up. Now, in order to solve this, well, the only difference really between this and the last problem, aside from the numbers themselves, is that now it's tangent. Still, I want to solve for y. It's over 13, so I'm going to multiply both sides by 13. So I'll have 13 times the tangent of 25 degrees is equal to, over here if I multiply by 13, I'll get rid of it, which means y is 13 times the tangent of 25 degrees. I want to see this on your paper. I want to see this on your paper. Now I do need to approximate this, so I'll grab my calculator again. 13 times the tangent of 25 degrees. 13, tangent 25, and I can close this. So this is 6.06 and then several other numbers. To the nearest tenth, 6.0619 and etc. is going to be approximately 6.1 because the 6 will force me to round up, the second 6 right there. So y is approximately 6.1. Okay. I've solved two problems. Now the third problem that follows is a bit different, so you do need to make sure you're paying attention to this. Here, I have a right triangle, an 18-degree angle. This side is 6. The hypotenuse right here is labeled as z. Alright, so if I'm looking from the 18-degree angle, 6 is the opposite leg, z is the hypotenuse. I'm not using the adjacent. What relates the opposite to the hypotenuse? Well, opposite and hypotenuse are related by sine. So the sine of 18 degrees is equal to, sine is opposite over hypotenuse. Opposite over hypotenuse gives me 6 over z. Alright, this is a bit different. Now, z is not in the numerator as x or y was in the previous examples. I have to think about this. Algebraically, what I need to do is get z out of the denominator so I can actually solve for it. So I will multiply both sides by z to get it out of the denominator. So z times the sine of 18 degrees is equal to 6. Well, that's all well and good, but I still need to actually solve for z. How I'm going to do that is divide. So I will divide both sides here by the sine of 18 degrees. If I do that, that means that z is 6 over the sine of 18 degrees. This is division. As you work through problems like these, you might notice a pattern, which is fine. Again, I want to make sure that you're putting your setup down here and you're telling me that z is equal to 6 divided by the sine over 18 degrees. So this is what I'm going to put into my calculator so that I can approximate z. Again, I grab my calculator. 6 divided by is what I need to enter. Sine of 18, and I close it. And what do I get? I get 19.416. To the nearest tenth, this will be 19.4. So z is approximately 19.4. again, a problem like this, it's not the sign that made this a more difficult problem. It was specifically where z was located on the triangle. So watch out for that. 6 over z, if I want to solve that using correct algebra, I have to multiply by z and then divide the sign back, which ultimately leads me to this answer. Z is 6 over the sine of 18 degrees. If I approximate that using a calculator, that is approximately 19.4 if I'm rounding to the nearest tenth. What is left to do with these trig functions? Well, next up I will be able to use these trig functions to take a given pair of sides and actually find unknown angles. Stay tuned.